Hi everyone, welcome to my MacPhi channel. Today we will discuss Euclid's division lemma and theorem. What is difference between these two? Lemma is nothing else. It is a proven statement used to prove another statement. Whereas theorem is a rule or principle specially used in math that can be shown true. Okay. Now, as for example, Euclid's division lemma. It is a restatement of long division process. That is Euclid's division lemma. Let us take an example of 35 is divided by 4. Now you have to think a largest multiple of 4 which is less than 35. As for example, 4 8s are 32 and after subtracting 32 from 35 we are getting 3. That is called remainder. That 3 must be less than 4. Okay, now we can write 35 in this way. 35 is equal to 4 into 8 plus 3, where 4 is divisor, 8 is quotient and 3 is remainder, and for 35 itself is a dividend. So it is true for any two positive integer a and b to have two other positive integers q and r such that a is equal to bq plus r, where 0 less than is equal to r and less than b. This is statement. This is proven statement which is used to prove another statement. Now we have to go through application based question of Euclid's division lemma. First we have to know definition of odd and even number by using Euclid's division lemma. We can say any number of the form of 2m is even. Why? Because when dividing by 2, it leaves no remainder. But if I am writing any number in the form of 2m plus 1, it is odd. Why? Because it implies when divided by 2, when 2 is divisor, then m is quotient and 1 is remainder. Since 1 is remainder, so it is not exactly divisible by 2, so it is odd number. So definition of odd number or even number is here based on Euclid's division lemma. Now, a number of the form of 3 to the power 4n minus 4 to the power 2n. When we are talking about 3 to the power 4n, so this must be odd. Since 3 is odd, there is no common factor 2 in this number, so it must be odd. What is 4 to the power 2n? Since 4 is even, then 4 to the power 2 is always even. We know odd minus even is always odd. Odd minus even is always odd. So we can say 3 to the power 4n minus 4 to the power 2n is always odd. Now we can say a number of the form of 7 to the power 3n minus 4 to the power 3n. 7 to the power 3n minus 4 to the power 3n we can write in the form of 7 to the power n to the power 3 minus 4 to the power n whole to the power 3. So it is of the form of a cube minus b cube. So it must be divisible by, it must have factor 7 minus 4 as a factor. 7 minus 4 is 3. So this number is divisible by 3, we can say. So for any bigger number, you can use this theorem, divisible by 3. Now, a number of the form of 7 to the power 2n minus 2 to the power 2n. 7 to the power 2n minus 2 to the power 2n. Here 7 to the power n whole to the power 2 minus 2 to the power n whole to the power 2, which is of the form of a square minus b square. So we can write this number is divisible by both, 7 minus 2 as well as 7 plus 2. That implies 5 and 9 both. 5 and 9 both. Next, a number of the form of, for a natural number, 6 to the power n minus 5 to the power n. First, we have to know 6 to the power 2n always ends with 6. Ends with 6. And 5 to the power 2n is always ends with 5. Ends with 5. So 6 to the power n minus 5 to the power n must ends with 1. Ends with 1. Why? Because 6 minus 5 is 1. So always ends with 1. Okay. Next, 2 to the power 5n, 2 to the power n into 5 to the power 2n has how many zeros? 2 to the power n into 5 to the power 2n, we can write in this form 2 to the power n into 5 to the power n into 5 to the power n. Now 2 to the power n and 5 to the power n, we can write 10 to the power n into 5 to the power n. So it ends with n zeros. Okay. Now what about any prime number? By using Euclid's division lemma, we can define prime number in a special way. Any number greater than 3, any prime number greater than 3 must be of the form of 6k plus minus 1. That implies if divided by 6, then it leaves remainder 1 or 5. Remainder 1 or 5. For any prime number, it is a general form of prime number. As for example, let us consider 101. So you have to divide 101 by 6. 6 1s are 6. 4 1 6 6 are 36. 36 means 5. Since remainder is 5, then 101 is a prime number. Prime number. Because we can write it in this form of 6 into 16 minus 6 into 16 plus 1. So it is of the form of 6k plus minus 1. So prime number can be defined. We can find out prime whether a number is given is prime or composite by using this form, that is application of Euclid's division lemma.